Hey everyone! In this video we have to analyze the convergency of this series. In order to define if this series is convergent or divergent, I'm gonna go for the ratio test. As we know, according to the ratio test, we have to define the limit as n tends to infinity of the absolute value of an plus 1 over an. If the answer of this limit is less than 1, in that case we are gonna say that the given series is convergent. If it is bigger than 1, we are going to say that it is divergent. Sometimes it may be equal to 1. In that case, the case is inconclusive, so we have to go for another test. Now, as in the formula, I have two terms, an plus 1 and an. It basically means that, firstly, I have to define them. Whenever you are given the series, in that case, the inside gonna give you an. So I'm gonna write here an as n minus 1 factorial divided by n plus 1 square. Now, in order to define the n plus 1 term, I have to basically plug n plus 1 in this expression instead of n. It is obvious that we have to simplify this expression further, so n plus 1 gonna give us n factorial divided by n plus 2 square. Now the next step is to divide the n plus 1 term to the nth term as given in the statement of the ratio test. So we will have an plus 1 over an. We just have to divide two fractions to each other. So when we have the factorial expressions, in order to simplify it, we have to express the bigger factorial in terms of the smaller one. In between n and n minus 1, obviously n is bigger, so I have to express n factorial in terms of n minus 1 factorial. And we are going to write this as n minus 1 factorial multiplied by n, since factorial is basically the product of the elements starting from 1 till that number inclusively. Now we can immediately eliminate n minus 1 factorials, and which is going to give us n times n plus 1 square divided by n plus 2 square. As a next step of the ratio test, we have to take the absolute value of this expression and take the limit as n tends to plus infinity. Since we don't have here any negative term, because n is the natural number, we can immediately get rid of the absolute values and immediately go for the limit. In order to define if the limit is bigger than 1 or less